look around you for a second, I mean, really think about it. That phone in your hand, the road you drove on today, the building you're in right now, even the food you trust, it's almost all been touched, shaped, engineered by someone. But what are the sort of hidden rules, the unseen principles making sure this complex world is, not just working, but safe, trustworthy? Today, we're taking a deep dive into something really fascinating and honestly critically important: engineering ethics. And this isn't just about like a list of do's and don'ts. It's the moral compass for the people designing and building almost everything around us. Our mission for this deep dive, we want to unpack the core ethical standards for engineers. We'll be looking closely at the National Society of Professional Engineers Code of Ethics, the NSPE Code, and then we'll bring it all to life with some really compelling real-world cases, some tough dilemmas, because engineers directly impact your life, your safety, your well-being every single day. Understanding their ethics gives you a whole new appreciation for the trust we place in them, maybe without even realizing it. Okay, so given that huge impact you just mentioned, where do engineers even start? What's the foundation for ethics in this field?
That's exactly the right question to ask. Fundamentally, ethics is about morality, the choices we make. But for professions like engineering or medicine or law, it gets much more specific, more formalized. Professional societies like the NSPE have these long-established guidelines, these standards. They're not just suggestions. They're the framework used to govern conduct, and importantly, to make judgments in complex ethical cases reviewed by their boards.
And the sheer scope of what engineers do, it's just mind-boggling, isn't it?
It really is.
Cars, computers, planes, medical devices.
Buildings, dams, highways, power plants.
Even things we don't always think about, like making our food supply safer, increasing crop yields, it touches everything.
And what's fascinating, or maybe sobering, is the scale of potential impact. Think about it. A surgeon, if they make a terrible mistake, might impact tragically one or two lives. But an engineer, a mistake in a bridge design, a faulty part in an airplane.
The consequences could be catastrophic, hundreds, even thousands of lives.
Precisely. And when you connect that to the bigger picture, it really underscores why there's just no room for error, for dishonesty in engineering. The stakes are incredibly high.
Yeah, you can't just say, oops, and move on. It's an ongoing thing, right? The source even quotes Confucius.
Ah, yes, the idea that not correcting a mistake is like making another one.
Exactly. It highlights that continuous responsibility.
It does. It's about vigilance. It's not just about the initial design. It's about performance, safety over time, and fixing things if they go wrong. That public trust you talked about, it's earned through that ongoing commitment.
And you, the listener, rely on that commitment every single day. When you use something safe, live in a secure building, you're trusting an engineer upheld those standards. So how do they manage this huge responsibility day to day? What's the guidebook?
That brings us to the NSPE Code of Ethics, right?
Exactly. That's the detailed framework.
Yeah.
And it's not just some document gathering dust on a shelf. It's actively used by the NSPE's Board of Ethics Review to analyze real cases, make judgments, and set precedents. It's a living document. Right. And the preamble kind of sets the stage, doesn't it? Talks about engineering as a learned profession.
Requiring the highest standards of honesty and integrity.
And having the direct vital impact on everyone's quality of life.
And therefore, the services provided must be dedicated to protecting public health, safety, and welfare.
Public welfare. That seems to be the absolute core.
It is. And that leads directly into the 6 fundamental canons. These are the absolute pillars, the core principles every engineer must follow. First, and this is the big one, hold paramount the safety, health, and welfare of the public.
Paramount. So, #1 priority above everything else. Client wishes, cost, anything.
Absolutely, non-negotiable. Second, perform services only in areas of their competence.
Okay, so stick to what you actually know.
Yeah.
No faking it till you make it when lives are on the line.
Exactly. You need the right qualifications, the right experience. Third, issue public statements only in an objective and truthful manner.
Straightforward honesty. No spin, no hiding uncomfortable truths.
Public trust depends on it. Fourth, act for each employer or client as faithful agents or trustees.
Meaning loyalty and diligence.
Yes, but always within the bounds of the other canons,
Mm-hmm.
especially public safety. It's not blind loyalty.
Got it. Fifth, avoid deceptive acts.
Pretty clear cut.
Yeah.
Honesty, transparency, no fraud, no misrepresentation.
Simple enough. And the last one.
Sixth, conduct themselves honorably, responsibly, ethically, and lawfully so as to enhance the honor, reputation, and usefulness of the profession. Basically, be a credit to engineering. uphold this reputation.
So those are the big six canons, high-level stuff. How do the rules of practice and professional obligations fit in? Are they like the detailed instructions?
That's a good way to think about it. The canons are the Constitution, the core values.
Yeah.
The rules of practice get more specific about day-to-day conduct responsibilities to the public, clients, other engineers. They translate the canons into actionable rules. And the professional obligations dive even deeper, covering things like giving proper credit, fair competition, things like that. It flows from the broad principles down to specific professional behavior.
Okay, that structure makes sense. Now, let's see how this all plays out in the real world. These case studies should really bring it home. Let's start with case 1, on competence. NSPE case number 983, the CD-ROM engineer. So picture this. Engineer A is a chemical engineer. No experience in facilities design or construction. 0. Gets an ad for a new CD-ROM claiming it makes designing any construction project, even highways, as easy as pointing and clicking, no matter your design experience. So Engineer A orders it and starts offering facilities design services. Okay, let's unpack this one.
Well, this is just a textbook violation of Canon 2. Perform services only in areas of competence.
Right. A CD-ROM doesn't give you years of structural engineering knowledge.
Not even close. It doesn't give you the education, the training, the practical experience, the judgment. What's really interesting here, though, is how tempting that shortcut might seem, in our tech-heavy world.
Yeah, the promise of an easy fix.
Exactly. But the ethical line is crystal clear when public safety is on the line. A tool is just a tool. It doesn't replace the engineer's expertise and ethical judgment. You trust engineers because they have that hard-won competence.
A really important distinction. Okay, case 2, public safety and notification. The hazardous material, case number 9911. Engineer A works at a plant using a toxic chemical, Mega X. News reports surface based on unconfirmed mouse studies alleging it could cause genetic harm in humans. Engineer A tells the manager, who basically says, "Not our department, the safety specialist handles that." Dismissive. Then 2 months later, nothing's changed scientifically, but the plant starts using more Mega X, exposing more workers. Does Engineer A have to do more even though the danger isn't fully confirmed?
This is a tough one because it's about potential risk, alleged danger, coupled with increasing exposure. It directly engages Rule of Practice 2(1)(a), which says if an engineer's judgment about safety is overruled, they must notify their employer and potentially other authorities.
Even if the science isn't 100% locked down.
Yes, especially when the potential consequences are severe and the exposure is increasing. The dilemma is balancing that uncertainty against the fundamental duty to public welfare, in this case, worker safety.
And imagine the pressure, right? The manager already brushed it off. Pushing back could be risky for Engineer A's career.
Immense pressure. There's fear of being wrong, of causing trouble, of damaging relationships or reputation. But overcoming that takes moral courage. It requires understanding that the ethical obligation to safety is paramount. It's about vigilance, about speaking up when risk escalates, even without absolute proof.
It really highlights the engineer's role as a kind of guardian, even when it's uncomfortable.
A moral sentinel, yes. Not just a technical expert. This case shows the gray areas, the judgment calls they have to make.
Okay, moving to collaboration and fairness. Case 3. Credit for work. Case numbering 2-1. Engineer A gets hired to design a bridge. A hires Engineer B, a specialist, to design the really critical, complex curved girder spans. Bridge gets built. Later, Engineer A enters it in a competition, wins an award, but completely fails to credit Engineer B for his crucial contribution. What's the issue here?
This directly violates Professional Obligation 3.9. Give credit where credit is due. Recognize others' work. It's not just bad manners, it's an ethical breach. It undermines professional integrity, teamwork, fairness.
So even on big, successful projects, acknowledging everyone's contribution is fundamental.
Absolutely. It reflects respect for colleagues and the collaborative reality of most significant engineering work. It's about honesty and representation.
Okay, one more case. Case 4. Honesty in professional assessments. This one involves a reference letter. Engineer A, a licensed principal, gets asked by Engineer B, a former intern now needing licensure, for a reference letter. The letter needs to vouch for Engineer B's experience, implying Engineer A was directly in charge. But Engineer A didn't personally supervise B's work for the whole period, so A asked someone who did have direct knowledge about B's experience. Based on that inquiry, Engineer A writes the letter. But crucially, A clearly explains the basis of the assessment, that it relies partly on this inquiry. Was that ethical? Pause.
The NSPE board said yes, it was ethical.
Really? Even without direct, constant oversight?
Yes, and the reasoning is key. Engineer A didn't lie. A didn't misrepresent their own qualifications or claim direct supervision where it didn't exist. By doing due diligence, asking the person who did know, and then being transparent about the basis of the recommendation in the letter.
Okay, so the transparency was crucial.
Exactly. A fulfilled an obligation to help a developing engineer while maintaining honesty. It shows the code isn't just about rigid rules, but about reasoned judgment, integrity, and supporting the profession, especially newcomers, transparently.
That's a great example of nuance in ethical application. It's not always black and white. So we've seen
Mhm.
the rules, the cases, but there's also something more personal, right? The engineer's creed.
Yes, the Creed, adopted back in 1954. It's less a rule book and more a statement of belief, like the Hippocratic Oath for doctors. It aims to summarize the core philosophy of service in engineering. You often hear it at graduations, licensure ceremonies. It's a touchstone.
Is it just ceremonial, though? Or does it actually, stick with engineers?
Oh, I think for many it really does resonate. It acts as this internal compass, especially when facing those gray areas we talked about. It captures the spirit of the profession, the privilege and the responsibility. It's about identity, not just compliance.
What are some of the core promises in it?
Well, it includes pledges like to give the utmost of performance striving for excellence, to participate in none but honest enterprise integrity in all dealings, to live and work according to the laws and the highest standards of professional conduct. And maybe the most powerful part, to place service before profit, the honor and standing of the profession before personal advantage, and the public welfare above all other considerations.
Wow, public welfare above all else. Again.
It's the recurring central theme, and it ends humbly. In humility and with need for divine guidance, I make this pledge, acknowledging the weight of the responsibility.
That phrase, service before profit, honor before personal advantage, public welfare above all, that feels like the absolute heart of it.
It is. It says a clear hierarchy of values. When faced with a choice between, say, a cheaper option and a safer one, the creed, if taken to heart, makes the ethical path clear. It's a commitment to prioritize the public good.
A profound commitment. So when an engineer builds something for you, the listener, chances are they've internalized these principles, perhaps even taken that pledge. Okay, so wrapping up this deep dive, we've looked at the core ethics, the NSPE Code, wrestled with some tough real-world cases, and reflected on the engineer's creed. Here's a final thought for you. How might these kinds of rigorous ethical frameworks apply in your work, or any field that impacts people's lives and relies on trust? What would your personal or professional creed look like? What lines wouldn't you cross? Something to think about. The next time you cross a bridge, use a reliable device, or just turn on your lights, maybe you'll have a new appreciation for the ethical commitment holding it all together. That immense trust we place in engineers day in and day out.